we present VLAD-Grasp, a method for zero-shot grasp detection using large vision language models. In VLAD, we first query a vision language model with an image of the object to grasp along with some grasp constraints, like the gripper width and configuration. Following this, the VLM generates an intermediate output reasoning about the object shape in context of the grasp constraints. Taking the example of the drone object, the reasoning highlights pinching near the midpoint of the body since that area is flat and rigid to allow better grip, narrow enough to fit within the max gripper width, and avoids fragile components such as the arms, guards, or rotors. Next, we query the VLM to design a prompt for editing the original image so that the generated image sees the object being impaled by a rod. Finally, we augment the generated prompt with additional constraints and query the VLM one last time to obtain the edited image. The rod in the generated image encodes in image space the antipodal axis for the goal grasp. From here, we lift both images to 3D by using sensor depth for the original image and predictive depth for the generated image. Using both object point clouds, we compute an alignment transform using PCA and correspondence-free optimization. This transform is then used to map the rod point cloud to the object in the original space, giving us the final grasp. The following are some real robot demonstrations for our approach. Also, some baseline models deployed for comparison. Finally, some worst-case scenarios for both our approach and the baselines. Finally, some worst case scenarios for both our approach and the baselines.